Before an earthquake shakes the ground, something sneaky might happen first. A slow, quiet movement with no shaking at all. No one is aware that right under their feet, the land is preparing to tremble violently, wreaking havoc, bringing destruction and devastation. A new study shows that such a slow creep might be how earthquakes begin. To figure this out, scientists didn't start with giant pieces of the earth. Instead, they went into a lab and used clear plastic sheets called plexiglass. They pushed two sheets of plexiglass sideways against each other, just like how tectonic plates, huge chunks of Earth's crust, push against each other underground. As they pushed, the plastic cracked, kind of like what the Earth does during an earthquake. And even though it was plastic and not rock, the physics, the way things break and move, was the same. Earthquakes happen when two tectonic plates try to slide past each other, but they get stuck. The edges between them don't move easily because of something called friction. It's kind of like when your shoes grip the ground. Over time, the plates keep trying to move and stress builds up. Think of it like bending a stick. At first, it doesn't break, but if you keep pushing, it will eventually snap. The spot where the plates are stuck is called a fault, and there's a thin brittle part in that fault. By brittle, I mean that it doesn't bend, it just breaks. Here's how it happens. First, a tiny crack forms. It's small and moves slowly. There's no shaking yet, but something is already happening under the surface. The crack spreads, building up more energy. When it finally reaches the edge of the brittle zone, boom! It speeds up, suddenly racing forward really fast, almost as fast as sound. And that's when the Earth starts to shake. So scientists decided to find out how that very first crack starts. They conducted their experiment, whose setup was similar to a type of fault in the real world called a strike-slip fault, like the San Andreas Fault in California. Even though the materials, plastic versus rock, are different, the way cracks form and move is exactly the same. The experiment has helped scientists understand that earthquakes don't always start suddenly. Sometimes there's a slow, quiet start, like a warning sign before the big quake. This early stage of an earthquake is called a nucleation front. It's like a seed of a crack, gently creeping through the material long before any actual rupture happens. This quiet and slow movement doesn't release energy into the surroundings. At first, scientists thought of cracks as simple one-dimensional lines, like a straight tear in paper. But something didn't add up. The slow-moving nucleation front wasn't behaving like a normal, fast-moving crack, and it wasn't clear why or how it suddenly sped up and became an earthquake. The answer came when scientists realized they had to think in two dimensions instead of one. Instead of imagining the crack as just a fine line, they began to think of it as a patch, like a growing circle, that starts at the surface where two materials touch. As this patch spreads out, more material along its edge has to break. The important thing here is that the energy needed to break the material is related to how long the patch's edge or perimeter becomes. The bigger the perimeter, the more energy it takes to keep breaking. That's why this patch moves slowly at first. It doesn't yet cause the violent shaking we associate with an earthquake. Because it moves without sending shaking waves, this stage is called aseismic. Eventually, the growing crack patch spreads beyond the special brittle zone, where the materials are stuck. Outside this zone, the energy needed to keep breaking the material doesn't increase anymore. Instead, there's now extra energy building up, more than what's needed to keep the crack growing slowly. This extra energy doesn't stay quiet. It suddenly powers the crack to move much faster, turning it into a full-speed rupture. That's the moment when the earthquake begins and the ground starts to shake. These findings help explain how earthquakes might start off slow and silent before quickly turning dangerous. They show that small, slow cracks can suddenly transform into powerful, fast-moving ruptures if the conditions are right. Scientists believe that they can learn to detect the aseismic stage before a crack speeds up. It might one day be possible to predict earthquakes, or at least understand the warning signs better. Now, even though earthquakes are only the third most common type of natural disaster, they cause the highest number of fatalities. NASA plays an important role in studying earthquakes by using satellites that orbit the Earth. These satellites collect data and images that show how the ground changes after an earthquake. For example, they can detect when the land shifts, rises, sinks, or cracks. These surface changes help scientists learn more about the strength and impact of earthquakes. NASA's satellites can also track changes in nighttime lights. If a city goes dark after a quake, that's a clear sign that the area may have lost power and could need help. Now, how about we talk about the most common earthquake myths, like the one about megaquakes? Some people really worry about super huge earthquakes, but there's a limit to how big they can get. The size of an earthquake depends on the size of the fault where it happens. A longer and deeper fault can cause a bigger earthquake. For example, the San Andreas Fault in California is long, about 800 miles, but not very deep, around 10 to 12 miles. This makes earthquakes bigger than magnitude 8.3 on that fault very unlikely. The biggest earthquake ever recorded happened in Chile in 1960. It had a magnitude of 9.5 and occurred on a huge fault that was almost 1,000 miles long and 150 miles wide. Technically, there's no set limit on the magnitude scale, but an earthquake bigger than magnitude 12 would need a fault larger than Earth, which just isn't possible. Now, earthquakes can happen near the surface or deep underground. Most occur in Earth's crust or upper mantle, down to about 500 miles deep. But the deepest ones happen only at subduction zones, places where one part of Earth's crust slides under another. In California, almost all earthquakes happen in the top 15 miles of the crust. One exception is the Cascadia subduction zone in Northern California, which continues up through Oregon, Washington, and Canada. Another misconception is that the ground can open during an earthquake, but usually that only happens in movies. A giant crack opening and swallowing things up during an earthquake is just fiction. In real life, the ground on either side of a fault slides past each other. It doesn't pull apart or open wide. Small cracks or holes can happen during landslides or ground failures, but not along the actual fault line itself. Faults don't open up because if they did, there'd be no friction, and without friction, there wouldn't be an earthquake at all. Now, some people think California could break off and sink into the ocean during an earthquake, but that's not how it happens. The ocean floor is just lower land with water above it. California can't fall in. What's really happening is that southwestern California is slowly sliding north toward Alaska along the San Andreas Fault. The Pacific Plate, which California sits on, is moving about 2 inches per year, about as fast as your fingernails grow. So, in about 15 million years, Los Angeles and San Francisco could be neighbors. And in 70 million years, Los Angeles might be sitting near Alaska. I can't wait. People often wonder whether an aftershock can be bigger than the earthquake itself. Aftershocks are smaller earthquakes that happen in the same area after a larger one. They're like our planet's way of settling down after the main shock. But if an aftershock turns out to be bigger than the first earthquake, then we call the bigger one the main shock, and the earlier one becomes a foreshock. About 5 to 10% of earthquakes in California are followed by a stronger one within a week. It's also possible for 2 quakes in the same area to be about the same size. However, very large earthquakes are rare, so it's even rarer to see 2 huge ones happen close together.
Check out the cool map of New Orleans, USA. See those bold gray lines around the city? Those are levees keeping the city safe from the red flood coming in from Lake Maurepas, Lake Salvador, and Little Lake. Without those levees, New Orleans would be in big trouble with rising sea levels. Even with the levees, the damage looks pretty bad. The Biloxi and Jean Lafitte Wildlife Preserve look like they're almost underwater on the map. New Orleans is not the only city in the U.S. that's at risk of going underwater. The city of Savannah is located right in the middle of Hurricane Central. But even without Mother Nature's fury, the place is facing some serious sea level rise. The Savannah River to the north and the Ogeechee River to the south might both overflow into the surrounding marshland. And that's not even the worst part. By 2050, there may be massive floods every year that will make history books look boring. Sorry to break it to you, but Miami is on the line too. The Sunshine State is shelling out around $4 billion to stop things from getting worse, especially in Miami Beach, a hotspot for tourists. As of now, over 1,200 houses are at risk of flooding. The Big Apple is also getting hit with more and more crazy floods. In November 2021, they even had their first ever flash flood emergency. But still, the city is not ready for it at all. Even the Statue of Liberty, one of the most famous spots in NYC, got messed up in Hurricane Sandy. Now with sea levels rising, Lady Liberty is in danger once again. Tabasco, Mexico is no stranger to flooding, thanks to its coastal location on the Gulf of Mexico. This low, flat state is covered in wetlands and forests and already deals with seasonal floods. But with sea levels rising, it could eventually be completely taken over by water. This would put at risk some seriously important things, like the Mayan ruins of Malpasito and Comacalco and Tabasco sauce. The sauce comes from Louisiana. Jokes aside, it's not just Tabasco. Parts of the Yucatan Peninsula and Baja California are also at risk from rising sea levels. Panama City is also in trouble. Apparently, the super trendy Casco Viejo and the swanky Costa del Este hood might get submerged in 2050, when Pedro Arias de Avila first founded it. Fun fact, it was the first European settlement on the Pacific coast. The 17th and 18th century forts on the Caribbean side are also in danger. According to Climate Central, they might get washed away by rising sea levels. Even UNESCO has had them on its risk list since 2012. Some more sad news. The Bahamas is going to be hit hard by rising sea levels. I mean, Hurricane Dorian was already a huge bummer in 2019. And now, they're saying most of Grand Bahama, Nassau, Abaco, and Spanish Wells could go underwater by 2050 due to various reasons. Amsterdam. The Netherlands is one of the Low Countries for a reason. The city and its buddies Rotterdam and Den Haag sit low and close to the North Sea. You gotta hand it to the Dutch though. They know how to handle the water and keep it at bay with high-tech flood defenses. With sea levels constantly on the rise, it looks like their impressive system of dikes, dams, barriers, levees, and floodgates is gonna get even more crucial in the future. Still, despite all the effort, some experts are afraid that the Venice of the North might go underwater by 2030. Well, this one is not something you would expect, but still. Venice is sinking by 2 millimeters every year, and the sea levels are rising. This means that the city is getting flooded more often, and it's only going to get worse because of climate change. Just like New Orleans, Venice has a flood defense system, but as the crisis gets worse, it's going to be harder and more expensive to keep it going. Even worse, beautiful St. Mark's Basilica has already been hit hard by flooding. They tried to introduce a flood barrier system, but even that didn't work out perfectly. In 2020, the flood barrier was not used and St. Mark's Square got majorly damaged. Looks like even when we try to prevent the effects of climate change, things don't always go according to plan. In London, rising sea levels are causing more flooding along the Thames estuary, and it's not looking good. Areas along the River Thames are especially at risk, putting iconic buildings like the Tower of London and the House of Parliament, as well as cultural hotspots like the Tate Modern and Shakespeare's Globe in jeopardy. And the British Museum? It has so much precious stuff, even Gollum would be jealous. We just can't let it go underwater. During your next Euro trip, make sure to add Bruges in Belgium to your list. Chances are you won't see it if you skip it this time. The thing is, it's also in danger of getting flooded. Bruges is now a UNESCO World Heritage Site, so we really hope they can protect it from any potential floods. Plus, it has a lot of nice local specialties we don't want to lose. You may not know it, but Andalusia in Spain is home to Western Europe's oldest city, Cadiz. It's been around for over 3,000 years thanks to the Phoenicians. But unfortunately, climate change is putting it at risk. Rising sea levels might flood the city's cobblestone center, beautiful tree-lined plazas and historic sea fortifications. And it's not just Cadiz. Parts of Andalusia are in danger of flooding too. Well, seems like one more destination must be added to your bucket list. Ho Chi Minh City, and especially its eastern marshy districts, are at risk, just like all the other places mentioned before. And it looks like the whole city is going to have a tough time with the Mekong Delta. While the main part of the city probably won't be completely submerged by 2030, flooding and storms are definitely going to become a big problem. So, it turns out that Bangkok might be in some hot water due to global warming. Literally, a 2020 study says that Bangkok could be one of the cities most dramatically affected by rising sea levels. It's sitting pretty low at just 5 feet above sea level. And to make things even more interesting, it's sinking at a speedy rate of an inch per year. And the cherry on top? The soil it's built on is super dense clay, which means it's basically a flood magnet. By 2030, parts of Bangkok, including the main airport, might have to get used to living underwater. The next city at risk is Kolkata, India. The fertile land in West Bengal has been a major key to their success for ages, but now it's causing some big worries in Kolkata and the surrounding areas. Just like Ho Chi Minh City, they could have some serious problems with all that rain during monsoon season. And the map of what could happen in 2100 is pretty scary stuff. The next destination is Shanghai, China. It's literally translated as the city on the sea, but it might actually end up under the sea. Climate control data is flashing red warning lights for this megacity, making it one of China's most at-risk cities. The Yangtze Delta, where Shanghai sits, and the Pearl River Delta, home to the Guangzhou, are both in hot water too, with lots of people living on low-lying land that might get flooded. The Maldives, a luxurious group of islands, already get flooded every year. Experts think they might lose 80 or even more % of their islands in the next 30 years. The Maldivian authorities aren't taking any chances though. They're already making plans to buy land in other countries, just in case they need to relocate the whole population. A leftover chunk of an ancient tectonic plate is on the move beneath North America, right under the southern part of the Cascadia subduction zone. This isn't some harmless debris. It's a real slab of Earth that never fully disappeared. And because it's still sliding around down there, it could be adding a whole new layer of stress to a region that already has a reputation for massive earthquakes. The story started with weird signals showing up in seismic data. It's basically Earth's X-ray. Scientists send waves through the ground and watch how they bounce back. These waves started acting wrong beneath the Pacific Ocean off the western US coast. Instead of smooth, predictable patterns, researchers saw a giant, coherent block deep below the seabed, moving differently from everything around it. It didn't look like a landslide, didn't look like loose debris, and didn't behave like normal ocean crust. That's when someone dared to ask the question out loud. What if this is something much older and much bigger than we thought? Some researchers seriously wondered if this could be a remnant of a lost continent, maybe a forgotten shard of Pangaea, the supercontinent that once stitched almost all land together. Technically, it's not fully impossible. Continents break, sink, stretch, and vanish over millions of years. This fragment was enormous, solid, and oddly shaped, which made it hard to classify. It didn't fit into the usual categories scientists use to explain underwater structures. Then came the slow, careful reality check. Scientists brought in more data, better models, and deeper analysis. They measured the age of the rock, studied how seismic waves bent through it, and compared its motion to known plate movements. That's when the picture shifted. This wasn't a lost continent at all. It was something just as dramatic, but far more dangerous. A massive leftover fragment of an ancient tectonic plate. This fragment turned out to be a survivor from the Farallon Plate. This ancient plate once dominated the Pacific, but got mostly swallowed as it slid beneath North America millions of years ago. Most of it vanished into Earth's mantle, but not all of it went quietly. This chunk survived like a splinter that never fully sank. Researchers named it the Pioneer Fragment, and the name fits because it's charting territory we didn't even know existed. And this fragment isn't just drifting harmlessly, it's moving horizontally beneath North America, which is weird and dangerous in geological terms. Normally, plates collide or slide past each other in predictable ways. This fragment behaves like a wrench jammed into a machine that already runs under insane pressure. The West Coast already balances on fault lines that store stress like stretched rubber bands. Add a giant moving rock slab underneath, and suddenly the system becomes harder to predict, harder to model, and much harder to feel safe about. The region where this fragment lurks already scares geologists. You've got the San Andreas Fault, famous for snapping without warning. You've got the Cascadia Subduction Zone, capable of producing earthquakes so powerful they rewrite coastlines. Now, scientists realize there's a hidden player deep beneath the ocean floor, something satellites can't see, and scientists can't directly observe. This fragment doesn't follow clean, predictable rules. Think of it like stacking dominoes on a table that's already shaking. It moves slowly, but in geology, slow movements still means unstoppable force. And when that built-up energy is finally released, it won't care about evacuation plans or building codes. There's also a timing problem that nobody likes to talk about. Geological processes don't run on human clocks. Stress can build for centuries and snap in seconds. The Pioneer Fragment might trigger something tomorrow, or it might sit quietly until generations forget about it. That uncertainty makes planning brutally hard. Cities like Los Angeles, San Francisco, and Seattle already prepare for known earthquake threats. Now, scientists must consider a system that can amplify disasters in ways nobody has practiced for. So, scientists now race to update models, improve seismic imaging, and understand how this fragment interacts with nearby faults. They know they can't stop earthquakes. All they can do is reduce surprises. And it's also clear that sometimes the most dangerous threats aren't coming from space, but sliding quietly beneath the sea. Another recent ancient landmass discovery wasn't nearly as dramatic, but super important for science. It started as a sand dredging operation off the coast of Indonesia, but then archaeologists found more than 6,000 fossil fragments from a lost submerged ice age landmass. Among them were 140,000-year-old Homo erectus remains. That single find forced scientists to rethink how early humans lived, moved, and interacted across Southeast Asia. For a long time, researchers assumed the Homo erectus population on Java lived cut off from everyone else. But those dredged-up fossils proved that Java wasn't an island. It sat right in the middle of a massive Ice Age landmass called Sundaland. Indonesia, Malaysia, Borneo, Thailand, and Vietnam are all connected into one enormous landscape. But we now call islands like Java, Sumatra, Borneo, and Bali were linked together through huge river systems that probably rivaled the Amazon. Dense forests stretched across the land. Giant animals roamed freely, and wide coastal plains existed where ocean waves sit today. And Homo erectus didn't just survive there, they thrived. And no, this wasn't a snowy wasteland, unlike how we mostly imagine the Ice Age. Sea levels dropped more than 400 feet because so much water was locked up in glaciers. When that happened, massive chunks of the ocean floor rose above the surface like natural stepping stones. Early humans didn't need boats. They could literally walk from mainland Southeast Asia to places we now think of as isolated islands. They moved while tracking animals, exploring open land, and following food sources. It worked like a giant prehistoric highway system. When the Ice Age ended, glaciers melted like forgotten ice cream cones on a hot sidewalk. Sea levels rose, slowly at first, then fast. Rivers overflowed, coastlines vanished. Entire human landscapes slipped beneath the waves. Over thousands of years, Sundaland drowned, and the people who lived there had to adapt or move to higher ground. Now, archaeologists piece together this lost world bone by bone, artifact by artifact. Every new discovery pulled from the seabed brings us closer to rewriting the story of early human migration. Studying submerged landmasses and lost continents is a work that takes years.
In 2017, scientists made an announcement that changed this universal truth that there are 7 continents in the world. The discovery of Zealandia. Zealandia's story ties straight back to Gondwana, the ancient supercontinent that started breaking apart hundreds of millions of years ago. Around 80 million years ago, Zealandia split off too. But while Australia stayed high and Antarctica mostly held its ground, Zealandia slowly sank. Only a small chunk stayed above sea level, even though many geologists argue it still qualifies as a full continent. That little bit you can actually see today is mostly New Zealand, along with a few nearby islands that also belong to Zealandia. By the end of 2025, scientists had finished mapping the northern 2/3 of it, covering nearly 2 million square miles of submerged land. Researchers dredged rock samples all the way from the Fairway Ridge to the Coral Sea. They pulled up all kinds of material: pebbly and cobbly sandstone, fine-grained sandstone, mudstone, bioclastic limestone, and even basaltic lava. And these rocks came from wildly different time periods. When researchers lined all this up, they saw something big. The internal stretching from both Zealandia and West Antarctica caused the crust to thin and crack in a way similar to subduction. That cracking let ocean water rush in and helped form the Tasman Sea. A few million years later, Antarctica continued pulling away, stretching Zealandia's crust even more until it thinned so much that sinking became inevitable. This directly challenges the older idea that Zealandia broke apart mainly through sideways strike-slip motion. The team also thinks the direction of that stretching shifted by as much as 65 degrees, which likely helped the continental crust thin out way more than expected.
What might be one of the fastest population collapses on the entire planet is happening right here, in a tropical holiday paradise. Welcome to Cuba, a country that is essentially evaporating. In just the last 5 years, roughly 10% of Cubans has packed their bags and left. We're talking well over 1 million people simply gone. I bet the biggest question comes to your mind right now. Why would anyone leave those beautiful beaches and one of the best climates in the world? Math is crucial here. Imagine working on a daily basis on your Monday to Friday job. It's been a tough month for you. And after all, you just earned just enough to get by. Maybe 50 or 60 eggs. Trading on the Cuban peso to US dollar and inflation in the country went wild. Results are dreadful. According to human rights monitors, nearly 90% of the population now lives in extreme poverty.
Hey, hit subscribe.
And also, historical irony might be a bit crushing. We used to call Cuba the sugar bowl of the world, but today the whole industry has collapsed. Sugar on the island is now often imported from France. It hits even harder when it comes to chickens. Cuba hasn't always had a good relationship with the US, but today it's from there that they import, among other things, chickens for their citizens. Money is not the only problem for Cubans. The whole country still runs on ancient Soviet power plants. They burn oil. For decades, the oil was basically shipped to Cuba at heavily subsidized rates from Venezuela. But the supplier got major problems now, and the oil stopped flowing. Cuba has gone dark, literally. Blackouts in some provinces can last even for 20 hours a day. It causes massive movement of people to the north. How massive? There's a wild statistic. Miami now has a GDP that easily doubles that of the entire island of Cuba.
In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice the size of a van began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails.
In the middle of the Pacific Ocean, the islands of Tuvalu are running out of time. A tiny country out in the Pacific, halfway between Australia and Hawaii. 9 small islands, all low and flat, surrounded by turquoise water and coral reefs. It looks like paradise from a plane window. You know, white sand, palm trees, endless blue. But it's disappearing, literally sinking. Tuvalu's highest point is only about 15 feet above sea level, and most of it sits around 6 feet. When storms hit, waves roll straight across the roads, wells fill with seawater, crops are ruined in the fields. Every year, the ocean creeps a little higher, and the ground seems to shrink beneath people's feet. And now, for the first time, the country is doing something no one's ever done before. They're planning an escape. This summer, the Australian authorities opened applications for a new kind of visa, the world's first made specifically for people forced to move because of climate change. This visa is part of the Australia-Tuvalu-Fallapili Union Treaty. Basically, it lets Tuvaluans live, work, and study in Australia with access to healthcare and schools, just like Australian citizens. Applications opened on June 16th and closed a month later, on July 18th. Within 4 days, more than 3,000 people had signed up, and that's almost a third of the entire country. By July 11th, the number had passed 5,000. For a nation of only 9,500 people, that's kinda shocking. So each year, 280 Tuvaluans will be chosen by a national ballot to move to Australia, starting in 2025. It's not a massive number, but it's enough to make a difference. But who gets to go first? Who stays? What happens when the land they're staying on starts to vanish? The science behind it is grim. In 2023, researchers found that sea levels around Tuvalu were about 6 inches higher than 30 years before. By 2050, large parts of the islands, homes, schools, the airport, could end up below high tide level. Saltwater is already seeping into underground freshwater supplies, ruining wells and soaking the soil. Farmers have started building raised garden beds to protect their crops from salt. And some families have stopped trying altogether and now rely on imported food. Australia and Tuvalu signed the Fallapili Union Treaty in late 2023. It covers a lot of areas, and migration is just part of it. The first group of migrants could arrive in Australia by late 2025. The annual limit of 280 people is meant to protect Tuvalu's economy and prevent a sudden drain of teachers, doctors, and skilled workers. But experts say that even at this slow pace, the country will change dramatically. If the numbers hold, around 4% of Tuvalu's population could leave every year, combined with other emigrations from the island country. In 10 years, that's nearly 40% gone. Hopefully, the people who go will still look back. Tuvaluans have always been ocean people, navigating by stars and reading tides. Their land and sea aren't just where they live, they're who they are. And leaving it behind means leaving part of themselves. It's a strange kind of rescue, one that saves lives but can't save home. Tuvalu is still standing today, green and beautiful, but the water keeps coming. So for the first time, the people are getting ready to leave before it swallows their world whole. But what is Tuvalu? It's one of those places that looks almost unreal on a map. 9 tiny dots in the middle of the South Pacific, halfway between Australia and Hawaii. Together, they make up a country smaller than most American towns. 5 of the islands are coral atolls, ring-shaped strips of sand and reefs floating on the ocean. The other 4 rise from the seabed. You could walk from one side of an island to the other in an hour, and the ocean would never be far from sight or sound. Tuvalu used to be known as the Ellis Islands when it was a British territory. It won independence in 1978, becoming one of the world's smallest and youngest nations. Since then, its leaders have fought to make sure the world doesn't forget about it, especially now as weather changes threaten to erase it completely. Life in Tuvalu has always been simple and pretty rough. There are no rivers or streams anywhere, so people rely entirely on the rainwater they collect in tanks and barrels. When the rains don't come, everyone feels it. Coconut palms cover most of the islands. The main export is copra, dried coconut kernel. But even that is changing. As seawater creeps further inland, it's slowly poisoning the soil. This makes the crops struggle to survive. Still, Tuvaluans are nothing if not resourceful. A few years ago, the authorities realized their country had something valuable no one else did: a 2-letter internet domain. They sold the rights to an American company, which now rents the address out to television networks and streaming platforms around the world. The deal brings in millions of dollars a year. That's a digital lifeline for a country fighting to stay afloat, literally and economically. But will the ocean treat them as kindly? You know how people always talk about sea levels rising because of weather changes? Well, it's not the first time that's happened, and the last time it did, it was bad. After the last ice age, global sea levels shot up by about 125 feet. That's like an 8-story building over roughly 8,000 years. And a recent study figured out how it happened. Basically, when the last ice age ended, giant ice sheets covering North America, Europe, and Antarctica started melting fast. Temperatures went up, ice turned into water, and that water had to go somewhere, straight into the oceans. Until recently, scientists knew sea levels had risen back then, but they didn't know exactly how much or how quickly because there wasn't enough data from that time period. So, an international team of scientists decided to dig, literally. They went to a spot in the North Sea called Doggerland, which used to be dry land. Thousands of years ago, you could walk from the UK to mainland Europe across it. It was full of marshes and low-lying plains where people and animals lived. But as the ice melted and the seas rose, Doggerland slowly sank underwater. So, the researchers drilled deep under the sea and pulled up samples of peat. That's old, partly decomposed plant matter that used to grow in those ancient marshes. By studying what was trapped in the peat, like tiny algae and bits of minerals, they could figure out how much the sea rose and when it happened. It turned out that sea levels had gone up by about 125 feet between 11,000 and 3,000 years ago. And it didn't happen all at once. There were two big jumps. The first major rise started around 10,300 years ago, when tons of meltwater poured into the oceans. The second big rise hit about 8,300 years ago, when more ice melted and massive glacial lakes dumped extra water into the seas. At the fastest point, sea levels were rising more than 0.4 inches a year. It doesn't sound like much, but that adds up to about 40 inches per century. For comparison, right now, sea levels are rising about 0.1 to 0.2 inches per year, and scientists expect that number to double or even triple by the end of this century. But keep in mind that back then there were no cities or highways or power plants sitting near the coast. Today, things are totally different. Billions of people now live in low-lying coastal areas, and a lot of the world's economy depends on those places. A rise like the one after the Ice Age would be catastrophic these days. The new research can help us understand how fast sea levels can rise when the planet warms quickly, and what that might mean for us now. Studying the past gives them a better idea of what to expect as modern ice sheets in Greenland and Antarctica start melting faster.
The Alaska Panhandle looks like a massive geographical mistake, and in fact it is. Someone drew this border based on mountains that literally do not exist, and today it's making life incredibly difficult for the people living there. How did the US end up owning this narrow strip of land that blocks Canada from the ocean? It all goes back to a bizarre agreement signed in 1825 between the Russian and British empires. Two superpowers sitting in Europe decided to establish a boundary through a wild, completely unexplored landscape. Making it follow the crest of the coastal mountains seemed to be a neat idea, with only one massive problem. Those mountains were a cartographic illusion. What they thought was a nice continuous ridge was actually a chaotic patchwork of peaks and fjords. Nope, they didn't check the terrain. You may wonder, why was it so important? When the US bought Alaska from Russia and gold was discovered in the region, this fictional line suddenly became highly contested. Who owns the coast simply rules. Back in 1903, an international tribunal stepped in and forced everyone involved to settle. The British judge sided with the US and the mistake was permanently locked in. Don't bring it up with Canadians nearby. It still angers them, as Canada was completely cut off from its ports, basically trapped behind a wall of land owned by the US. The issue is still valid today, and it's not just about old paper maps. Reality on the ground is harsh. The border they settled on is an absolute logistical nightmare. It completely fractured local ecosystems and split indigenous territories, like those of the Tlingit and Haida people, right in half. For the residents of these remote border towns, the daily impact is severe. because of how awkwardly this line slices through the landscape. Towns like Skagway, Alaska are only reachable by road if you drive through Canada. Meanwhile, Canadians living near the edge often have to cross international checkpoints just to reach the nearest hospital, buy basic groceries, or put their kids on a school bus. Imagine everyday life is dictated by Border Patrol. This jagged line is a stark reminder that borders are not just ink. When a boundary is based on total cartographic fiction, but enforced as hard fact, it's the local people who pay the price every single day.
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where 2 major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where 2 tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler. Well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front row seat to a natural fireworks display, thousands of feet beneath the waves. The live stream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from Northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia Subduction Zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while. You can't even imagine how much benefit trees can bring. In the first half of the last century, America built a forest in the prairie states with the only scope to help countless people survive the Dust Bowl. That's what people called the devastating period of the 1930s, when the country faced extreme drought that destroyed farmers' fields. You've probably never heard of it, but America's forgotten green wall, made up of forests, saved an entire country from devastating problems. It all began in the 1930s. Severe droughts destroyed vast amounts of crops. Farmers were terrified. Powerful winds swept sand and dust across fertile fields, polluting and damaging the soil. The hurricanes also accelerated erosion and evaporated moisture, leaving the ground dry and barren. Cornfields and other grains produced almost nothing. A serious famine was approaching. That's why on July 21, 1934, President Franklin D. Roosevelt instructed a U.S. Forest Service to begin the Great Plains Tree Planting Project. Sounds great and promising, but how did America stop the Dust Bowl exactly? The idea was to plant as many trees as possible in long, wide, straight rows. These rows of trees were meant to act as a shield, protecting fields from strong winds, preventing erosion, and reducing drought. The tree belts also provided shade, cooling the soil and nearby water sources. They protected crops from wild animal pests and supplied people with an extremely valuable material, wood. In short, it was a massive climate restoration project. The Forest Service established headquarters in Lincoln, Nebraska, as well as in several towns and counties across Oklahoma. The official launch of the forest building effort took place on March 18, 1935, in the city of Mangum on the H.E. Curtis Farm, when the first shelter belt was planted. You might think that planting trees is simple, but you'd be wrong. It's not just a matter of tossing seeds into the ground, covering them with soil, and adding a little water. Let's take the pecan as an example. It's a fairly large tree with a wide, dense crown. If you choose to plant seeds directly into the soil, you'll need to spend a great deal of time and effort fighting weeds and pests. A seed requires more care and attention than a sapling because it's far more vulnerable. You don't just water the tree, you need to develop a proper irrigation plan. You don't skip meals during the day, so a seed also needs to receive water regularly. But don't overdo it. Too much water can destroy the tree. Many factors must be considered, such as soil temperature and fertility, so don't be surprised if nothing works out at first. A more reliable method is planting a sapling. You bring a young tree into a field, dig a hole of the appropriate size, moisten the root system, trim the roots and branches slightly, place it in the hole, and cover it with soil. As you fill the pit, the soil must be compacted. At the end, water the ground to firm it up. Cut off half of the tree's top to balance the root system. And by now, your head is probably spinning from all this information, but this is only the beginning of the work. As the tree grows, you need to paint the trunk white or wrap it with special protective covers to shield it from the sun and other damage. Don't forget about weeds and grass. They don't harm the tree directly, but they compete for the same moisture and nutrients the pecan tree needs. Then some insects and pests eat the tree and spread diseases. You have to choose special treatments to eliminate all these threats. So yes, planting a tree is not that simple, and we're talking about just one pecan tree. Meanwhile, America built a forest filled with mulberry trees, Osage orange, cottonwood, green ash, hackberry, red cedar, walnut, and many other types. Every day, farmers cared for all these trees. They watered them, fertilized the soil, removed weeds, fought pests, all under extreme heat. Of course, planting such a forest required more than just farmers' efforts, so the federal government actively supported them. If a farmer wanted to establish a shelter belt, they submitted an application. Special commissions evaluated the land designated for planting and tested the soil. If the land was fertile, the authorities approved the request. From that moment on, farmers began planting. Special government crews helped farmers build fences and fight rodents and weeds. Overall, it was a collective effort that produced impressive results in the form of well-structured forest rows. Each tree in a row was spaced about 10 feet apart. The width of the shelter belt ranged from 100 to 165 feet. Considering that the selected tree species had dense foliage, each belt formed a thick barrier that acted as a filter, cleaning the air of sand and stopping the wind. To improve the effectiveness of this filter, farmers planted tall trees in the central rows, shorter trees along the sides, and shrubs at the edges. The American Reforestation Project became so massive that by 1942, 220 million trees had been planted across 18,000 miles, stretching from North Dakota to Texas. Of course, not everything went perfectly. Some shelter belts were severely damaged and later removed by farmers. Many trees and shrubs suffered from intense droughts and locust infestations, and in some areas, farmers prepared the soil incorrectly. In 1936, tree survival rates were around 73%. In 1937, maintenance was fully transferred to farmers, and the rate soon dropped to about 61%. But why did damage increase once the government handed over the project? Farmers did their jobs well. Perhaps the problem was scale. It's extremely difficult to take care of such a vast forest, even with experienced people. It could happen that while farmers in Kansas were fighting locusts, powerful winds in Oklahoma were uprooting trees. But was the man-made forest in America worth it? Yes, the forest helped to a certain extent, but overall, it didn't save fields from the Dust Bowl as effectively as people hoped. But those trees became homes for countless birds and animals. Some internet users claimed that in the 1950s, people saw a lot of pheasants in this area. Even today, according to forums, these birds still live in the old forest belts. Nowadays, locals see many trees in the prairie states and probably assume they appeared naturally. Few people know that all of this is the result of the hard work of many farmers, and that the real reason why America built a forest was to save the country. It's important to remember that. Today, the country is not threatened by drought or massive crop destruction as far as we know. Famine is not expected either. But why is it still important to preserve these shelter belts? Yes, they are vital for nature and support many animal species, but beyond that, they have very practical benefits for people. They protect the topsoil from strong winds. In winter, they keep roads from being buried under snow. Think about how blizzards can completely cover highways with thick, white drifts. Rows of trees significantly reduce snow accumulation. Farmers also plant tree belts between their farms and nearby roads. This creates a natural shield that protects animals and plants from dust, exhaust fumes, and traffic noise. So you can create such a shelter belt too. No, seriously. Many people dream of having their own garden or a single small tree. But what about an entire forest? Imagine how rewarding it would be to walk through it many years after planting. The farmers who created this massive shelter belt were surely happy about all the work they had done. You may be curious what's happening to the Great Plains shelter belt today. Does it still exist? By 2010, the condition of many shelter belts had declined. Dense planting, aging trees, and the spread of other species competing for moisture and nutrients have all weakened these shelter belts. People have almost forgotten the American Reforestation Project. Fortunately, during those same years, the government allocated funding to maintain these forests in Kansas, North Dakota, South Dakota, and Nebraska. So there still may be a chance for them.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. And there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes or dolenes. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though. Glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own, like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes. They're well adapted to living in dark waters and usually stay close to the lake bed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these, where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people notice there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
Canada is massive, but almost everyone lives in the east or the west. And right in the middle, there is this huge stretch of land where hardly anyone calls home, Northern Ontario. So why does this place almost feel off limits? Northern Ontario is part of, well, Ontario. It's a super busy province, home to major cities like Toronto and Ottawa. About 1/3 of all Canadians live there, but most of them are down in the southern part of the province, not up north. But that doesn't really add up when you think about it because the northern part is way, way bigger. We're talking about a region that is more than 300,000 square miles, pretty much the same size as the whole country of Turkey. Northern Ontario takes up about 87% of the entire province. But, strangely, only about 6% of Ontario's population lives in this area. But before you start dreaming about moving there for some peace and quiet, hold on. There are 4 big reasons people choose not to, and honestly, you'll probably agree. Reason number 1, the land itself. Look up the region on Google Earth, and all you will see is a huge stretch of empty space. Nothing special at first glance, but zoom in, and that's when things start getting complicated. Northern Ontario is famous for its rugged, remote landscapes, full of endless forests and lakes. It's beautiful to look at or snap a photo of, but living there is a whole different story. The geography makes the area tough to get around and makes it hard to build things like transportation routes and railways. And since it's so difficult to put decent roads up there, the whole region stays pretty isolated. That takes us to reason number 2, remoteness. You might think that, being in the center of the country, it could serve as a great link between the eastern and western parts of Canada. But in reality, that's not how it works, and the region is very far from Canada's major cities. Take Greater Sudbury, the largest city in Northern Ontario, with around 160,000 people. The closest major city is Toronto, which is about 230 miles away. So yeah, that's roughly a 4-hour drive just to get there. If you're planning a holiday weekend in a big, dynamic city, a 4-hour drive sounds like a fun road trip. But if you need to go for a dental appointment or sort out paperwork, that distance suddenly feels endless, not to mention the cost. Unfortunately, that's how life is for many people up there. Residents of Northern Ontario don't have easy access to opportunities or services. With so few people scattered across such a huge area, the region doesn't have enough facilities, infrastructure, or easy access to essential services like healthcare and education. People there sometimes have to deal with poor or even non-existent infrastructure, like missing roads, airports, hospitals, and schools. Without those things, settling down is really tough. And in rural areas, it's even worse, because the lack of services can seriously hurt their quality of life. Psychologically speaking, that's not great either. People can end up feeling isolated and lonely, and the freezing weather doesn't help. Which brings us to reason number 3 why most people don't live in Northern Ontario: the harsh climate. If you're not a fan of cold weather, you should definitely leave this region off your travel bucket list. Winters up there can be long and brutal, with temperatures sometimes dropping as low as 40 degrees below 0 Fahrenheit. Have you ever tried shoveling snow when it's this cold? Yeah, it's not exactly fun. That kind of harsh weather doesn't just mess up your weekend plans or your daily jog, it also makes transportation a huge challenge. The result is that many residents end up isolated from essential services and job opportunities. And it's also really hard to build infrastructure, grow industries, or run businesses because of that harsh climate. Take farming, for example. Compared to Southern Ontario, the northern region has a shorter growing season and much colder weather. Although crops like oats, potatoes, and green beans can handle the cold, the climate usually limits the variety of things that can be grown. That's why most farms are concentrated in the southern part of the province, and in other parts of the country, like the prairies and Quebec. Anyway, that's just one example of how the climate makes it tough for people to build a strong foundation to support themselves. And that's exactly the 4th reason why Northern Ontario is so empty: the economy. It's not that there aren't any jobs available. In fact, there are plenty. In 2023, the northern part of Ontario had some of the highest job vacancy rates in the country. So unlike in many parts of the world, it's a place where they have tons of jobs available, but no people to fill them. One reason people don't take those jobs is that many of them are older. Just look at Elliott Lake, for example. 42% of the people living in the city are over 65 years old. That's the 3rd highest concentration of older adults anywhere in Canada. But it's not all that different in the rest of the region either. Estimates show that by 2036, people aged 65 and older will make up almost 30% of Northern Ontario's total population. And do you see what happens when they hit 65, right? They've got their pensions, and going back to work just isn't on the radar. This problem only gets worse because young people just don't seem interested in living there. Every year, lots of students around 17 or 18 years old pack their bags and either drive across the province or fly across the country to study somewhere away from their northern homes. And many of them don't come back. But that's actually pretty strange considering the region does have a strong economy, especially in mining. Take the Red Lake area, for example. It's packed with gold. In fact, it's home to one of the richest gold deposits in the world and has already turned out over 30 million ounces of the metal. That's definitely helped Canada stay ranked among the top 5 gold-producing countries in the world. Then, there's this region, known as the Ring of Fire. It's centered around McFaulds Lake in the Kenora district and covers about 1,900 square miles. It's rich in valuable minerals like chromite, cobalt, nickel, copper, and platinum. These days, Northern Ontario's mining industry is making a big comeback and attracting new investments. That's happening because the world is suddenly desperately looking for critical minerals. By that, I mean essential elements used in modern technologies like smartphones and renewable energy systems. Minerals like cobalt, nickel, and copper are especially important for making the batteries that power electric cars, for example. So, right now, it seems like the whole mining scene in the region is doing pretty well. But the industry has gone through plenty of ups and downs, with fluctuations and periods of decline. And that, combined with the possible lack of variety and jobs outside the mining industry, means people are more likely to leave the region in search of better opportunities. Interestingly though, mining companies are now struggling to find enough skilled workers in Northern Ontario. And that's probably because of all the reasons we've already talked about: an older population, harsh weather, tough geography, and a long distance from major urban centers. So, it's basically a cycle. And local authorities are trying to break out of it by improving infrastructure in the region, offering more incentives, and finding ways to keep young workers from leaving. Some of their strategies include offering cash rewards to people who refer healthcare workers for job openings or providing tax-free payments to help cover higher home energy costs. And there are plenty of other initiatives too. So yeah, with strategies like these, it's definitely possible to grow the population there. And who knows, maybe one day this region could be bustling with people.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit. But the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
It looks like a tropical paradise, yet today, almost no one is allowed to visit. Deep in the Pacific, 1,000 miles south of Hawaii, lies one of the most restricted territories in the United States, Palmyra Atoll. For decades, it was fueled by wild speculation, whispers of pirate treasure, military cover-ups, or a curse that drives visitors to madness. But the reason for this strict isolation isn't military secrets or ghosts. It's because of biosecurity. This island is a living time capsule, one of the last pristine coral reef ecosystems left on Earth. The rules here are strict because humans are dangerous. A single introduced bacteria, a stray seed on a shoe, or one invasive rat could collapse the entire food web. To protect this biological treasure, the island is effectively sealed off. However, Palmyra's uniqueness goes beyond biology. It holds a bizarre legal history where a single family stood their ground against the United States government. Why? Because they had the receipts. A private family, the Fullard Leos, had bought the entire atoll legally in 1922. When Washington tried to assert total control over the atoll, claiming it as a public land and strategic territory, Fullard Leos said, "No, it belongs to us." Most people would have backed down against a superpower. The Fullard Leos did not, and they sued the United States of America. The legal battle was exhausting and long, eventually reaching the highest level, the United States Supreme Court. In a landmark 1947 ruling, the court delivered a stunning verdict. They ruled against the government in favor of the family. The Fullard Leos were declared the rightful owners of this American territory. It remains one of the rare times private citizens successfully claimed sovereignty over land against the federal government. So what did the family do with their private kingdom? They didn't build a hotel or a casino. In 2000, the family made a deliberate choice and sold the atoll to the Nature Conservancy for about $30 million, ensuring it would never be developed. Today, the island is managed as a strict research station. It remains empty, not because we forgot about it, but because a private family fought the government to keep it that way. The isolation is intentional. Palmyra is closed to the public, so it can stay open for nature.
Something enormous is hiding right below Hawaii, deeper than any drill could ever reach. This strange underground bubble, almost 1,800 miles down, tells us impressive new details about the formation of the islands and could cause an eruption that will affect thousands of lives. Scientists call strange formations like this blob ultra-low velocity zones. When earthquakes happen, they send vibrations through the planet, and they move fast through most rocks, but they slow way down when they pass through certain deep layers. That slowdown tells geologists something unusual sits there. The giant blob beneath Hawaii belongs to the biggest category of these structures, a mega ultra-low velocity zone, a massive chunk of material sitting right on the border between Earth's mantle and its core. To find out what this monster actually looks like, scientists track two different types of earthquake waves. The first type, pressure waves, compresses rock like squeezing a spring. Another type, shear waves, moves rock up and down like shaking a rope. When they combined both signals, researchers built a much clearer picture of what lies deep below Hawaii. Scientists used to think that this blob was soft and partially melted, like thick lava slowly rising toward the surface. But this new seismic data showed that the blob isn't gooey at all. It's mostly solid rock, dense, heavy, and packed with iron. This discovery helps explain a real mystery that puzzled scientists for decades. Most volcanoes form along the edges of tectonic plates. But Hawaii doesn't sit anywhere near one of those boundaries. It floats right in the middle of the Pacific Plate. Yet the islands somehow form from some of the most active volcanoes on the planet. They used to explain this with a hot spot, a column of heat rising from deep inside the Earth like a blowtorch slowly melting its way upward. But now, it turns out that the giant iron-rich blob anchors that heat plume in place, like the base of a lava lamp that keeps the flow steady for millions of years. The material the structure is made of could even be leftovers from a basal magma ocean, a gigantic layer of molten rock that may have existed deep inside Earth when the planet first formed. When that ancient ocean cooled and crystallized, heavy elements like iron sank downward and created dense pockets, and the blob under Hawaii might be one of those survivors. Now, structures like this don't just sit quietly forever. Heat constantly flows through Earth's mantle, and when those flows shift, they can tug on deep structures, redirect heat, and sometimes destabilize them. If the system beneath Hawaii ever changes in a major way, it could intensify the volcanic activity above. We already see hints of that restless energy. Hawaii has thousands of earthquakes every year. Most of them are tiny, so small that only sensitive instruments detect them. On average, Hawaii has about 100 magnitude 3 earthquakes per year. Those are strong enough for people to feel. Roughly 10 quakes reach magnitude 4 annually, and about 1 magnitude 5 quake shakes the islands every year. Bigger events happen less often, but they still happen. Most of this activity is going on around the Big Island, which has several volcanoes. In early March 2026, Kilauea launched fountains of lava nearly 1,300 feet into the air. Bright red streams of molten rock blasted upward, and ash and volcanic fragments rained down across nearby areas. Authorities temporarily closed parts of Hawaii Volcanoes National Park and sections of Highway 11 because falling debris created dangerous conditions. The eruption didn't threaten homes directly, but it still caused real problems. Ash drifted across nearby communities, and tiny rock fragments coated roads and rooftops. All that activity connects to the same deep engine, the hotspot anchored by that enormous iron-rich blob nearly 1,800 miles beneath the islands. Now, let's travel north, where something pretty scary lurks beneath the western edge of North America. Something capable of reshaping the entire coastline. Scientists think that 2 giant earthquake faults, the Cascadia subduction zone and the San Andreas fault, don't just exist side by side, but may actually affect each other and act like giant dominoes. Cascadia stretches along the Pacific Northwest, and the San Andreas cuts through California. Scientists found evidence for this possible impact on the ocean floor. They pulled long cylinders of mud and sediment, and these cores are like geological history books that preserve layers of debris from ancient earthquakes. Inside those layers, researchers saw that pairs of earthquake deposits sit almost on top of each other. Geologists call them doublets. 2 massive quakes struck so close together in time that the ocean barely had time to settle between them. And that discovery points straight to one of the most chaotic tectonic zones on the planet, the Mendocino Triple Junction. This is where 3 tectonic plates collide and grind together, like crooked gears inside a machine. It's also the exact place where the San Andreas Fault meets the Cascadia subduction zone. Now, when one fault ruptures, it sends shock waves of stress through the crust. That stress can destabilize the neighboring fault and push it toward breaking too. A Cascadia megaquake alone could reach magnitude 9 or higher. That kind of earthquake could tear open 600 to 700 miles of seafloor and send a massive tsunami racing toward the Pacific coast. And if Cascadia ruptures first, the shifting stress might trigger the San Andreas shortly afterward. In the worst-case scenario, people in California could feel one enormous quake, watch buildings sway and highways break apart, and then see a second disaster just minutes later. And the opposite sequence could happen too. The San Andreas could snap first, redistribute pressure through the crust, and nudge Cascadia to failure. In this case, people living in the affected area might survive the first quake and then see the ocean suddenly pull away from the shoreline. And that's the chilling signal that a tsunami could arrive in about 20 minutes. Scientists know from analyzing the sediment that this sequence has happened before. There were at least 10 paired earthquakes over the past 3,100 years. The scariest part is that a new massive earthquake isn't about if, it's strictly about when. Now let's jump across the Atlantic to southern Italy. Just west of Naples, there's a massive volcanic system called the Campi Flegrei caldera. It means something like burning fields, and it earned that title honestly. About 109,000 years ago, a huge eruption blasted ash and rock across the region. It removed more than 36 cubic miles of magma from beneath the surface. It's a volume close to the massive eruption that formed the Campi Flegrei caldera around 40,000 years ago. That earlier eruption carved a crater about 9 miles wide and spread volcanic ash across huge parts of Europe. Today, more than 400,000 people live directly inside that ancient crater. The soil there feels incredibly fertile because crops have grown on broken-down volcanic ash for centuries. But the same geology that makes the land productive also hides enormous energy underground. Researchers recently studied ancient rock layers preserved in mountains and deep boreholes around the region. That's how they found out that Campi Flegrei may produce giant eruptions more often than scientists previously believed. That doesn't mean a catastrophic eruption will happen anytime soon, but it does change how researchers see the long-term danger. When these eruptions occur, they don't behave as ordinary lava flows. They generate pyroclastic flows, and those are fast-moving avalanches of hot gas, ash, and rock that race across the ground at highway speeds. Some ancient deposits from that eruption, more than 100,000 years ago, reach more than 6 feet thick in certain places, which proves just how violent the bang was. When you connect all these discoveries together, you once again see that our planet doesn't just sit quietly beneath our feet. It moves, breathes, and occasionally reminds us who really runs the place. And most of the time, the biggest forces shaping our world hide thousands of miles below where we stand.
You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it.
Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare, so for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and meconium, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the Big Island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands. Miami's luxury towers have everything. Car elevators, rooftop pools, celebrity neighborhoods, and something completely unexpected called gradual descent. A new study shows dozens of beachfront high-rises are slowly sinking into the ground. Just a couple of inches over a few years and still moving. What's going on? And is it gonna get worse? Let's find out. When you look at a map of South Florida, the city of Miami is mostly on the mainland. Just off the coast lies a long barrier island. That's Miami Beach, the stretch you see in most drone shots and travel clips. Fancy cars, the beach, the clubs, the glass towers right next to the water, that's all on this island. But it didn't always look like that. For a long time, this area was mostly older hotels and simple apartment buildings. As prices went up and richer buyers started chasing ocean views, developers began knocking those down and putting luxury high-rises in their place. Floor by floor, that island turned into a narrow wall of glass facing the Atlantic Ocean. Now, here's the problem. Miami Beach sits only 4 to 5 feet above sea level. That's barely enough height for comfort. Each fall, king tides push water up through drains and across certain streets on bright, clear days. The flooding sometimes gets so bad that locals could kayak through parking lots for fun. That might sound like a funny video, but for researchers, it raised a serious question. Could the same landscape be shifting beneath the towers too? Some buildings had already shown signs of movement, and the question became whether the ground itself was still settling under all that concrete and steel. To find out, scientists used a method called INSAR, which stands for Interferometric Synthetic Aperture Radar. It works by having satellites scan the same spot on Earth over and over using radar to detect tiny changes in elevation. It's like watching a tower in slow motion from space, tracking whether it holds steady or slowly sinks. Those scans stack hundreds of satellite passes over the same balcony corners and roof edges. It's the same kind of radar NASA uses to track volcanoes and ground shifts. With enough images, researchers can spot motion as small as the thickness of a credit card. Between 2016 and 2023, they focused on this section of coastline from Sunny Isles to Miami Beach. The data showed that at least 35 high-rise buildings had moved downward over that period. In some cases, the ground had dropped just under an inch. In others, it was closer to 3. That may not seem like much, but over a short time, and in structures this heavy, it means something's off. These weren't new buildings under construction. Most were already finished, which makes the continued movement unusual. In theory, they should have settled and stopped, but they didn't. So what exactly is making the ground sink under these towers? Let's look underground, specifically right under these nice-looking buildings. Beneath the island is a mix of sand and Miami limestone. It is strong enough to build on, but it behaves more like hardened coral than solid mountain rock. Water moves through it, pressure moves through it, and sometimes the ground shifts in ways engineers can't properly predict. One possible explanation is something called creep deformation. It sounds like a villain from a B-movie, but it's actually a slow-motion rearranging of particles under constant pressure. Imagine parking a heavy truck on soft ground. It makes little dents right away, but if the truck stays there for a long time, those dents slowly get deeper. The ground keeps squishing a tiny bit at a time. That slow squishing is what might be happening under these buildings. But it's not just the weight. Construction itself can wake the ground up. Pile drivers, excavation, and heavy machinery can shake the sandy layers enough that older buildings nearby start shifting again. The study also found that some of the newer towers showed stronger movement overall, likely because the soil beneath them was still adjusting after recent construction. And then there's the water. The limestone underneath acts like a sponge, soaking up water from the ocean below and the rain above. When that water moves around, it quietly eats away at the rock and shifts the sand that holds everything up. That's how the ground slowly loosens. So, we have a spongy ground, heavy buildings, and the constant shaking from construction. Plus, water flowing through the rock. Over time, all of that adds up. It presses down just a little at first, then a little more. We're only talking inches, but even small uneven shifts can be enough to make engineers nervous. So, what does this mean for the buildings and all the people making social media reels? Probably, and hopefully nothing. At least not tomorrow. We're still far away from disaster movie scenarios. Structures won't topple over. There won't be sudden sinkholes swallowing cars. It's not how it works. But this problem does raise some eyebrows, especially after what happened just a few miles north in Surfside. In 2021, the Champlain Towers South partially collapsed. It was a huge tragedy that Miami will remember forever. That disaster didn't happen just because the ground moved. Issues kept piling up slowly over the years. Engineers discovered cracks, rust, and bad drainage. The building was falling apart from all sides, and then it was too late to do anything about it. But since then, the city has been paying more attention. Engineers are reassessing older buildings near the coast, and local officials are pushing for stricter inspections. The radar data doesn't mean a building is unsafe, but it can be an early warning. A signal that something deserves a closer look. For residents, though, there's a catch. Right now, there's no rule that says developers or building managers have to monitor ground movement with satellite scans. The study didn't involve teams going inside or taking core samples. It was just a space-based scan from above. If you zoom out from the sinking tower drama and look at that long strip of land, it's already one of the weirdest pieces of real estate on the planet. A good portion of the Miami lifestyle is literally fake land. Star Island, Palm, Hibiscus, the Venetian Chain, and a bunch of other spots started as sand at the bottom of Biscayne Bay. The bay was dredged in the 1920s. The sand was piled into islands, and developers turned those piles into celebrity neighborhoods where houses now cost tens of millions of dollars. Some of the richest people on Earth treat this area like their private game board. Fisher Island, just off South Beach, currently has the most expensive zip code in the United States, with a median listing price in the 8-figure range. A bit farther up sits Indian Creek, known as the Billionaire Bunker. It has only 41 houses, its own police force, and neighbors like Jeff Bezos and Tom Brady. One empty 1.8-acre lot there was recently listed for around $200 million, just for the dirt and the view. And all of this floats along the edge of Biscayne Bay. next to an actual national park full of beautiful marine creatures like dolphins, manatees, and sea turtles. More than 100 bottlenose dolphins live in and around the bay year-round, racing past boat docks and tall condos like they're extras in someone else's movie. So, what happens next? Engineers keep scanning, inspectors keep checking, and everyone online keeps posting drone shots like nothing odd is happening under their feet. That's Miami, a strange blend of glamour and physics that never quite behaves. It's not a crisis, it's a maintenance routine. As long as the people in charge pay attention to quieter signals like slow dips in elevation or small structural changes, the skyline should hold. Maybe it settles a bit, maybe it stretches and groans. Now that engineers and scientists are aware of this issue, they can prepare and propose solutions. Until then, the towers will still be up and the bay will still shine bright. The whole city will keep drifting in its own style, just slightly downward.
Now, you might want to book your dream vacation to Miami Beach as soon as you can, because this whole area might be underwater in the next 75 years. But it's not just Florida. Parts of Louisiana, California, and Washington are also expected to be among the first American states affected by sea level rise. If you live in the United States, you can check for yourself whether your address is on the list of cities that will disappear. Just search for Sea Level Rise Viewer on Google. That will take you to a tool created by the National Oceanic and Atmospheric Administration. And it helps us visualize what coastal flooding might look like in the future. Now, you see that dark area in blue? Those are the sinking cities of the U.S. And by that, I mean cities that could be submerged by 2100. That's in the worst-case scenario, if ocean levels were to rise by as much as 10 feet. Hopefully, it won't come to that. As you probably know by now, sea levels are going up because the Earth is getting warmer. When the planet heats up, ice at the North and South poles melts, and all that extra water flows into the oceans. Plus, warmer water expands and takes up more space. So, between the melting ice and the expanding oceans, sea levels slowly rise over time, and that means more flooding and even the possibility of some cities ending up underwater. Right now, statistics show that sea levels are expected to rise by around 6 feet by the year 2100. The problem is that this could cause major coastal flooding, and not just during storms or heavy rains. Even on clear days, some areas could end up underwater. And that brings us to a question. How do we actually know how high ocean waters are? These days, experts can measure sea level with incredible accuracy, thanks to satellite altimeters. That's basically a special type of radar that measures how high something is. It figures out the height of the ocean by timing how long it takes for a radar pulse to travel from the satellite down to the surface of the sea and then bounce back. When scientists combine that data with the satellite's exact location, they can map even the tiniest changes in sea level all over the world. Right now, coastal flooding predictions are showing us something serious. The rate of global sea level rise has doubled over the past 3 decades, and there are plenty of tools online that help us to visualize just how big this problem could become in the future. The Sea Level Rise Viewer I mentioned earlier focuses on areas within the United States. But if you don't live there, you can still check if your address might be in danger. Just look up the interactive map from Climate Central. If you set the water level to 10 feet above the high tide line, you'll see that a lot of countries could be seriously affected. Let's take a look at South America. In Argentina, for example, rising waters could flood many parts of Buenos Aires province. Head over to Brazil, and you'll see that a lot of cities, including Rio de Janeiro, would be affected. We might have to say goodbye to that iconic wave-patterned sidewalk along Copacabana Beach, and both of the city's airports would be flooded too. Things don't look much better in Europe. Major cities like Lisbon in Portugal, Valencia in Spain, and Rome in Italy could end up partly underwater. Honestly, the worst situation in Europe is probably in the Netherlands. Right now, about a quarter of the country is literally below sea level, and nearly half of it sits just 3 feet above. So if sea levels rise, they are facing some serious risks. This entire red zone, which includes cities like Amsterdam and Rotterdam, would be below the surface if the ocean rose by 10 feet. Fortunately, the Netherlands is probably the country with the most experience in fighting back against the sea. For years, they have tackled the threat with massive infrastructure, things like giant canals, windmills, and dikes, all designed to manage the water. And thanks to their efforts, the Dutch have reclaimed about 20% of their land from the sea. That's right, they're actually expanding. Unfortunately, some countries are at much higher risk than others. According to estimates, about 5 of them are in serious danger of disappearing in the near future. First up is Fiji, a tropical paradise loved by tourists. This nation is in a tough spot because of its low-lying landscape. There, extreme warming could cause sea levels to rise by as much as 6 feet by the year 2100. It doesn't help the fact that Fiji sits right in the middle of the Pacific Ocean, where massive storms can quickly turn things into chaos. That means people there need to brace themselves for more frequent flooding, and they're already taking action. To protect against coastal erosion, some communities are lining the seashore with old tires to keep sand from washing away in stronger waves. Others are planting mangroves across the coast. These trees can reduce the height of waves hitting the shore by an average of 31%. Plus, they help cut down wind speeds, which really matters during cyclones. Next on the red list is Vanuatu. This chain of islands, located between Australia and Fiji, could be underwater sooner than we think, and they're already making changes. Vanuatu is one of the first Pacific nations to relocate an entire community to safer ground. Back in 2005, people living in vulnerable areas on the North Island of Tegua moved to higher land. With temperatures continuing to rise, they're bracing for even more intense tropical cyclones. That means heavier rainfall, more flooding, and a much higher risk to both homes and infrastructure. The Marshall Islands are also facing a serious risk. This country is home to around 39,000 people and lives on the opposite side of the world from the United Kingdom. It's an extremely low-lying island nation built on what's basically a coral reef. According to NASA, sea levels there have risen by almost 4 inches over the past 30 years, and they could rise by about 7.5 inches over the next 30. And that's no small thing. If nothing is done, the islands could face more than 100 days of flooding every year by the end of the century. People over there are afraid of losing their homes. Studies also show that up to 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't ready to give up, and they're reinforcing the infrastructure. The Solomon Islands are also being slowly swallowed by the sea. This region has been experiencing sea level rise at nearly 3 times the global average. Over the years, satellite images have shown that 5 vegetated reef islands have already vanished beneath the waves. On the bright side, the people there are working hard to protect their homes. They're building stone walls along the coast and planting mangroves to hold back the water. But the worst case might be Tuvalu, as it could become the first country to turn completely uninhabitable because of rising seas. This island chain, located about halfway between Australia and Hawaii, sits only about 9 feet above sea level. And in its narrowest spot, in a place called Fungafale, the land is just about 65 feet wide. You can see how vulnerable the situation is, right? I mean, even before the higher tides arrive, the country's limited farmland could be affected by salt water. These islands are a powerful example of resilience, and a reminder that sinking cities don't have to mean disappearing ones. While the challenges are real, the global response to sea level rise is growing stronger every day. Around the world, communities are adapting, innovating, and coming together to tackle the threat of rising water. Imagine you're standing on the edge of New York's Seneca Lake on a quiet summer day. The water is glassy and still. Somewhere nearby, a sailboat drifts past, and a couple of kids are skipping stones near the dock. And then, without warning, boom! A big rattling blast tears across the lake like a cannon firing somewhere out on the water. Birds scatter, glasses rattle on porches half a mile inland. People on the shore freeze and spin around, scanning the horizon for smoke, a boat, anything. There's nothing. No storm, explosion, or whatever. No source at all. Just an enormous, echoing silence where the sound used to be, as if the lake had simply exhaled and gone quiet again. Now, imagine that happening not once, but again and again for over 300 years with nobody able to explain it. That's exactly what's been happening near Seneca Lake in upstate New York, and not just there. The same booming sound has been reported all along the East Coast, from New Jersey down to Florida. Locals gave it a name, the Seneca Guns. For 3 centuries, that name was all about anyone had. With no real explanation in sight, people filled the silence with stories. Some believed it was the voice of a powerful spirit, shaping the land or expressing anger. Others were convinced it was the echo of old battles still replaying themselves across the water, fought over and over by ghosts who never left. The story even made its way into literature, with one famous 19th century novelist describing it as a sound like distant artillery, as though the lake itself was speaking back to the surrounding hills in a language nobody could translate. Generations later, as technology advanced, the guesses got more dramatic. Whispers of hidden experiments happening just out of sight, strange aircraft testing the limits of speed high overhead, or something unworldly slipping beneath the surface of the lake. People hundreds, even thousands of miles away, near other lakes and coastlines around the world, reported almost identical sounds and came up with their own versions of the same theories. The wilder the story, the longer it tends to stick around, especially when nobody can actually prove otherwise. And for 300 years, nobody could. And here's the twist. The answer was finally hiding in plain sight the whole time at the bottom of the lake itself. It started almost by accident. A team of researchers were using sonar to scan the lake bed, but they weren't even looking for the source of the booms. They were searching for old shipwrecks resting somewhere in the depths. Seneca Lake is enormous, holding around 4.2 trillion gallons of water, and astonishingly deep, plunging as far as 618 feet down in some spots, deep enough to swallow sonar signals and sunken boats, without leaving much of a trace behind. But while mapping the bottom, the team stumbled onto something nobody expected: craters. Not 1 or 2, but 144 of them, scattered across the lake floor like a field of giant footprints, each one roughly 30 feet deep and 400 feet wide. That's deep enough to swallow a several-story building whole, and wide enough to stretch across more than a football field. Scattered like that across the bottom of the lake, they look less like natural dips in the mud and more like scars left behind by something violent, repeating itself again and again for a very long time. So the team collected samples, water pulled from the darkest depths, sediment scraped from the most undisturbed corners of the lake bed where nothing had been touched in years. When the results came back, one substance stood out clearly above everything else: methane. That single discovery finally confirmed a theory scientists had floated for nearly a century without proof. Almost 100 years ago, a geologist had already guessed that gas bubbling up from deep underground rock could be exploding at the surface with a booming sound. Decades after that, another scientist suspected something almost identical: bubbles of methane breaking through the mud below the lake. Both of them were right all along. They simply didn't have the technology yet to prove it. So the idea sat quietly untested for generations, dismissed as a guess rather than an answer. Here's how it actually works. Deep beneath the lake bed, ancient organic material, old plants, decomposed sediment built up over thousands of years since the lake first formed, slowly breaks down. As it decomposes, it releases methane gas. Now normally, gas like that would just leak out gradually, bubble by tiny bubble, rising so slowly that nobody would ever notice it happening at all. But at Seneca Lake, layers of dense, heavy sediment trap the gas instead of letting it escape upward in small, harmless amounts. So, instead of leaking out, it builds. Pressure accumulates for years, sometimes even longer, squeezed tighter and tighter beneath the sheer weight of everything sitting above it. Eventually, the pressure becomes too much to hold back. Yep, I can relate to that. The trapped gas punches violently upward through the sediment and through the water above it, with enough raw force to physically carve out a hole in the lakebed in the process. That's exactly how those 144 craters got there. Each is essentially the fossil of an old explosion, a permanent scar left behind from the exact moment the pressure finally won the battle. But the craters only explain the holes left in the mud. The sound comes from something else entirely, a shock wave. When a massive pocket of compressed gas suddenly bursts free, it sends a powerful pressure wave rippling outward through the water and up into the air above it. That shock wave is the boom, essentially a small natural explosion. And explosions, even small natural ones, are loud. Seneca Lake has one more trick that makes the sound even more dramatic: its sheer scale. With a lakebed reaching roughly 200 feet below sea level and water depths exceeding 600 feet in places, the lake works almost like a giant natural amplifier. All that water focuses and intensifies the shock waves as they travel upward toward the surface, turning them into the deep rolling blasts that sound exactly like cannon fire echoing across the water. No wonder people spent 3 centuries assuming an actual weapon had to be involved somewhere nearby. There's a bigger story here too, beyond just one lake in upstate New York. Seneca Lake itself was carved out by a massive glacier that melted away at the end of the last ice age, leaving behind the deep basin we see today. For scientists, this isn't just a quirky local mystery worth solving for its own sake. It's a useful clue for understanding how much gas might be quietly building up under similar deep lakes elsewhere around the world. Some of those lakes, in other parts of the world, can release methane in quantities intense enough to actually pose a real danger to nearby life, not just an unsettling sound. The good news for everyone living near Seneca Lake: this isn't one of those cases. Researchers say the booms, while loud and startling enough to make anyone jump, pose no real danger to nearby communities or the wildlife living around the lake. And interestingly, the frequency of these eruptions seem to be slowing down compared to past decades. A small relief for anyone who isn't particularly fond of being woken up by cannon fire in the middle of the night. So, the next time the water seems to growl beneath your feet on a calm summer afternoon, you can rule out angry spirits, secret experiments, or anything otherworldly drifting beneath the surface. It's just centuries worth of quietly buried gas, finally loud enough to be heard after centuries spent building up the nerve to escape from underneath the lake. So yes, the lake farts. Mystery solved, and somehow, after 300 years of ghost stories and wild theories, the real explanation might be even more fascinating than the legend ever was. Because the truth turns out to be a story about patience, a quiet, invisible gas waiting underground for years, sometimes decades, slowly gathering its strength until the ground simply can't hold it anymore. Nature, it turns out, didn't need ghosts or secrets to keep an entire region wondering for 3 centuries. It just needed time, pressure, and one good squeeze.
There's something really bizarre going on at these 12 points scattered across the Earth. The vile vortices, as they're called, are these creepy spots over the Tropic of Cancer, the Tropic of Capricorn, and the North and South Poles,
where weird forces seem to take over. You've probably heard of the most famous one, the Bermuda Triangle. It's believed that more than 50 ships and 20 airplanes have mysteriously disappeared in this area, which is located between Florida, Bermuda, and Puerto Rico. But what most people don't realize is that the Bermuda Triangle actually has 11 siblings, and these other spots can be even more terrifying. Let's start with Mohenjo-Daro. This was a thriving city located in what is now Pakistan. Built around 2500 before the Common Era, this urban center was once home to about 40,000 people. But then, suddenly, people abandoned it by the year 1700 before the Common Era. In the 1940s, an archaeologist discovered 39 human skeletons at the site, which fueled the theory that the city was invaded by some other civilization at some point. But honestly, it's hard to confirm that, since archaeology doesn't really explain the city's sudden destruction or the disappearance of its people. It's led to a bunch of bizarre theories. One of them talks about an ancient extraterrestrial race that might have lived there, and a malevolent wind that swept through the city. Another ancient city with a similar mystery is the Great Zimbabwe. Its construction began in the 11th century, and at its peak it housed up to 18,000 people. But for reasons we'll probably never fully understand, it was abandoned in the 15th century. Archaeologists were really interested in this place, and that's when things got even weirder. They found 8 of these birds, now called the Zimbabwe birds. These soapstone sculptures were found sitting on stone columns that were over 90 centimeters tall. Nothing like them has ever been found anywhere else, and their meaning is still a total mystery. Some think each bird represents a new king, but other theories suggest they were ancient animals very dear to the people who lived there. Adding to the mystery, local legends talk about a strange, short man who's sometimes seen wandering around, but he always disappears before anyone can get close. Then there's Easter Island, another one of the 12 vile vortices. It's located in the eastern Pacific Ocean, and it's famous for its nearly 1,000 enormous statues called moai. We still don't know what they mean, or how they were made. Some of them are almost 30 feet tall and weigh as much as 80 tons. Today, it wouldn't be that tough to move and carve these statues, but we're talking about a period between the years 1100 and 1680. So nobody really knows how they did it. Some specialists believe these statues were carried across the island, while others think they were pushed on log rollers. But the most bizarre theories suggest extraterrestrials were involved. Algeria is another land rich in ancient mysteries, and one of the most fascinating is something called the Djedars. These are 13 monuments with square stone bases and angular mounds, built between the 4th and 7th centuries. But the weird part is, no one knows their purpose. One of them had an inscription in Latin, but it was so worn down that the message was nearly impossible to read. The best guess so far is that these monuments were probably tombs for royalty, although no one knows exactly who was supposed to be buried there. What we do know is that there are many myths related to strange disappearances in the region. The next mysterious spot is located south of Tokyo in the Pacific Ocean, and it's called the Dragon's Triangle. Does that name ring a bell? Yep. Just like the Bermuda Triangle, this area is known for strange disappearances of airplanes and ships. One of the most chilling stories dates back to 1945, when a plane allegedly vanished. The pilot supposedly sent a radio transmission right before the aircraft disappeared, claiming that something strange was happening in the sky, like it was opening up or something. While this story is definitely eerie, the truth behind it and many other Dragon's Triangle legends is still up for debate. If you type Hamakulia volcano into Google Earth, you'll find it located in Hawaii's Ring of Fire. But this place is so shrouded in mystery that it's hard to find much information about it. Some legends speak of unusual electrical energy being detected in the area. And there's even a story about an eyewitness who claimed to see a plane flying over it totally disappear from the radar. Another eerie spot is the South Atlantic anomaly, which is an area on Earth where natural radiation flows out of control. While this doesn't affect our daily lives on the surface, it has a pretty big impact on Earth's atmosphere. The radiation there is so intense that it can knock out the onboard computers of spacecraft and interfere with the data collected by satellites passing through the area. To deal with this, specialists had to add an additional shield to the International Space Station. The South Atlantic anomaly is also linked to a weird event that astronauts experience called cosmic ray visual phenomena. They've reported seeing random flashes of light or shooting stars out there in space, but it's all just some kind of illusion. From wild radiation to strange seismic activity. The Wharton Basin in the Indian Ocean is a place known for unusual tectonic events. In April of 2012, a massive earthquake measuring magnitude 8.6 hit the region. This was considered the largest intraplate earthquake ever recorded, meaning it happened within a tectonic plate rather than at its boundary. This caught the attention of scientists, who now speculate that the region might be forming a new boundary between the Australian and Indian plates. But for now, this is all still one big mystery. Now let's head to the Pacific Ocean. More specifically, to the New Hebrides Trench. This submarine trench is about 750 miles long and 45 miles wide. It formed when the Australian plate slid under the New Hebrides plate. There's no doubt that this is one of the creepiest and deepest spots in the ocean. The danger isn't just down in the deep sea either, as this trench has been connected to several earthquakes that affected New Caledonia and Vanuatu. This area also has some strange features. For example, when scientists explored it, they didn't find a single grenadier fish down there. This type of fish is one of the most common deep-sea creatures you would expect to see in trenches around the Pacific. So why aren't they around the New Hebrides Trench? Maybe they know something we don't. The two remaining vile vortices are the North and South Poles. These two are on the opposite ends of the planet, but they share one thing in common: strange disappearances. One of the most famous stories from the North Pole happened in 1897. 3 brave explorers set out on a journey to reach the North Pole using a hot air balloon. But they never completed their mission. Their mysterious disappearance remains one of the most intriguing, unsolved mysteries in the history of Arctic exploration. The South Pole is also known for similar mysteries. It's believed that hundreds of people may be buried beneath the snow and ice of the coldest continent on Earth. Even with all the advancements in technology and knowledge, the South Pole can still be extremely dangerous for anyone who ventures there. The temperatures can drop to almost minus 130 degrees Fahrenheit, and the winds can get up to 200 miles per hour. And that's definitely enough reason to stay away. Now that you're familiar with the 12 vile vortices, let me tell you something even stranger. If you look at a map, you'll see that these places are arranged in a way that looks pretty similar across the globe. Here's the weird part. If you connect these spots where unexplained events have occurred, you actually form the geometric shape of an icosahedron. This could be just a huge coincidence, but the fact that these mystery spots align with this shape makes them even more intriguing. Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches. and that's a carefully measured long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean geoid low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine.